Hello and welcome to the RapidMiner demonstration. Today we'll be working with the flights dataset. The first goal with any data science project obviously is to get the data. RapidMiner provides various data access operators in the data access group here, or if you are trying to read, a simple search for the word will provide you a list of various places that RapidMiner can read the data from. In this case, however, since the data is in a CSV file, rather than using a read CSV operator, I'm going to import the data using the wizard, which makes it easier. We're going to first look at our 2007 dataset. Everything seems correct so far in this screen. We'll go ahead. I know my CRS departure time is of the type time and its format is hour, minute. So I'm going to specify that, and the same goes for my CRS arrival time. So we'll change that too. Other columns seem to be fine, so we're going to hit next here and specify a location. I'm going to save it in the data folder with the name flights 2007. We could rename it later if needed, and hit finish. At this point, RapidMiner goes ahead, pulls the data, and it's importing it into its own repository. We'll eventually repeat the same workflow for the 2008 flight data. Once the data set are loaded, our first task is to explore the data. So I'm going to right click and hit open. That will open up the data set for us to review. Here I have the raw data set itself. Obviously I could scroll through and see the details, but I can quickly switch over to the statistics tab. Here RapidMiner provides a quick summary of the data that we have. So obvious things like the name of the columns, the data types, if there are any missing values, it seems quite a few in some columns. Uh, Depending on the column type, other details like minimum, maximum deviations, and a distribution chart. For now, I'm going to focus on the origin column here, so we can search for the origin column, and I quickly see that there are about 300 odd airports. My top airport is ATL, followed by ORD. ORD is in Chicago, which has weather issues, so we will focus on ORD for now. So along with that, there are also some data points in here which are about delayed or cancelled or diverted flights. So we're going to get rid of that data since they may influence our model in the incorrect fashion. So let's go ahead and take those corrective actions first. So I go back to the design tab. What we're going to use now is RapidMiner operators. These operators are small units of functionality that you can add to build a workflow. So my first step is bring in the 2007 data set itself, and then we can look for operators to start filtering out the data set. So if I want to filter examples, filter rows, I can bring in that operator, and then I can start specifying my condition here on the right. So in this case, we are going to say origin equals ORD, or I could have just picked it from the list that is available here. Also, I want to ensure that we are not looking at cancelled and diverted flights. So the flag for that is a 0, and we'll specify that as the value and hit OK. So by doing this, I have set up the necessary condition. I can do and, or, and so on. We're going to now focus on our goal. So for departure delay, I see that the average value is around 11. So we'll consider anything above 15 as a delayed flight. Also at the same point, you'll notice my arrival and departure time are including minutes. So I probably want to round it up to the hours. So let's go ahead and do that in the design tab. RapidMiner provides various operators for generating new columns from existing columns. The most powerful one is the generate attributes, where you can write expressions. So I bring in that, and we'll first specify the delay flag. So I'm going to specify if condition. If my departure delay flag is greater than, let's say 15, then it's delayed. Otherwise it's considered on time. And we'll hit OK. We'll call it the delay flag. Similarly for the hour, I'm going to get a function called as date underscore get. Our column of interest is CRS arrival time, and I need to extract the hour part of it. So we'll include that, and this will be my arrival hour. We will repeat this for the departure hour. So let's go ahead and do that. CRS departure time, and the hour part of it will be called departure hour and hit apply. At this point, we probably don't need to generate any new columns for now, so we'll be good here. Now let's focus on the columns that we probably are going to use for our analysis. Some columns we obviously know are not going to be useful. So looking at the list, I can select which columns I want to use. So to do that, we'll go back to the design tab again, and we will use an operator called as select attributes and provide. Notice RapidMiner provides some automatic ways to get rid of group of columns or remove useless columns or correlated columns based on deviations or other logics. But for now, I'm going to specify which columns to exclude. So we'll specify subset, and we will start selecting our columns. Arrival hour is good. We want day of week. Day of month may be important later, so we'll keep it. I want departure hour. Destination obviously is important. A flight number, maybe, I don't care. Month is important. Origin is important, and carrier is important, and the year is important too later on for with combining with the weather data. So we have created the workflow to get the raw data, get rid of our non-diverted, non-cancelled flights from O'Hare, generate a few new columns, and select appropriate columns that we want to use. I could attach some notes here to kind of guide somebody who's going to use this later on, and we'll talk about collaboration a bit later. But the idea is I could attach note to individual workflows or specific roles. Our next part is telling RapidMiner which target column. So we use the set role operator to do that. I can specify my delay flag is my label, that is my target. I can specify additional roles like IDs, predictions, cluster, etc. if needed. But for now, this should be good. At this point, I should be able to store this data set, which is my ORD data set. We are going to save it in this ORD folder here and specify the location as data ORD 2007 flights and hit OK. I can simply run the workflow and then the results will be available. But before we do that, since we are going to repeat this set of steps for 2008, I'm going to select them, move them into a new sub process, basically grouping them. And then I'm going to save this as a building block so that I can easily use all those 3 steps again in my 2008 data prep. So we are going to say data prep for flights data. So to repeat that, what I can simply do is we can bring in the 2008 flight data. I'm going to use the sub process like we did before. I could have copy pasted, or we're going to use that insert building block like I said earlier. So that takes in the input of the data set, and we can then store it again as 2008 ORD dataset. So there's a lot of emphasis on reusability and shareability. These building blocks can be shared across a broader community on community.rapidminer.com. So let's save that workflow so that we can go back if needed, and we'll call this prep flights data. Now that we have the data set for 2007 flights, let's go ahead and explore it further. I'm going to filter this out to only my delayed flights so that we can see what affects. So I can simply say the delay flag is equal to delayed and hit OK. Once I run this workflow, I can go back to my charts view and we can explore the data in various visual formats here. RapidMiner provides various rich capabilities. For now, if I stay with the histogram, for month, obviously I see the month of December, the month of February, there seems to be a pattern emerging. These are winter months, high travel seasons, obviously kind of affects the delays. Day of the month, nothing really great. Day of the week, again, some patterns, but nothing concrete. If I look at it from arrival hour perspective or a departure hour perspective, obviously you see a very clear trend that the departure hour and arrival hour influences. Delays seem to be kind of increasing at towards the end of the day. So obviously we have some visual techniques here available. Obviously I could further explore this, but instead of doing it in a visual format, I could also start using various statistical techniques. So RapidMiner provides various extensions and inbuilt operators for statistical analysis of the data. So obviously there are a plethora of those here. If you are looking to find outliers, there's a whole set of operators around outliers that are available. But for now, I just need to find weight of my columns, which columns affect. So we're going to bring in, let's say, one of these several weighing techniques, and we're going to configure to see what the output looks like. So we'll run it one more time. But obviously this is 0 because everything was delayed, so I need to get rid of my filter, and we'll run it one more time. And what I see here is, like we saw, the departure hour followed by arrival hour, month, destination are important. In this technique, I'm doing it by one. I could obviously bring in another operator. Let's say I want to compare these two. I could keep building on this workflow and get the two results simultaneously. But what I have also done is I tend to combine few of these techniques and get an average, and I have saved that previously as a building block, again one of those reusable components. So I'm going to delete this, and I'm going to insert my favorite building block for identifying influence factors. This automatically creates a series of steps that combines weights and averages and normalizes them, but I can simply reuse it. We have the final output here, score between 1 and 0 normalize, and again similar to what we saw, but this is very clear indicator of what we saw visually as well as by some of the techniques. So I now know how these factors are important. Obviously, I may be able to do something like creating a dummy variable for each departure hour and each month and see if there are specific months that stand out. But before we do that, let's go ahead and save this workflow here first as determine influence factors. Like we said, now we need to do dummy coding of our data. RapidMiner provides various type conversion operators for numerical to binomial and various formats. So in this case, I'm going to first convert my numerical columns to polynomial, and I will select the subset of columns, and that will be my arrival hour, departure hour, and month, and apply. Please notice I'm selecting subset, but there are other various techniques to empower the user with various selection mechanisms. And once I have done the polynomial one, I need to now convert it to a binomial that will use a dummy coding. So we'll again select the same subset. That will be my departure hour, arrival hour, and the month, I believe, and hit apply. And we'll rerun the workflow one more time. As you notice in the output here, the factors that we saw earlier obviously seem important. 12th month, which is the holiday season, obviously seems to be terrible, followed by some early morning hours and some late evening hours. And then February, I guess it's because of the winter and so on. But as you notice with several key additions, now we have a clear understanding of what's going on, what impacts our performance of flights. Obviously, we see that the weather plays an important role. So the next step we are going to do is get some weather data. We are going to rely on Weather Underground. This provides an API for getting airport data. I can pass in the airport code, the start date and end date parameters, and it provides me a lot of weather related data, which we'll see in a second here. But obviously there are hundreds of airports, so we need a way to variabilize this. So what I'm going to do here is start on a clean slate. We are going to get our 2007 flights data. RapidMiner provides advanced operators like looping on individual values of a particular column, unique column. So I'm going to use the loop value on destination. The value will be stored in loop value. And then inside of that, we are going to use RapidMiner's web mining extension to start pulling the data. The web mining extension is another rich set of functionality that lets you do crawl websites, get individual page or pages, do some HTML processing and so on. In this case, I'm going to use the getPage API, and rather than passing in a hard-coded value, I'm going to pass in the variabilized URL, which is going to be replaced by the loop value every single time the loop runs. So we're going to provide that. The next part of this is when it downloads, I need to write this out file somewhere so that I can process it later on. So I'm going to write the document, and then we are going to provide the path here. Notice I have again used the loop value variable so that it creates a file with the airport code as a name. And just so that Weather Underground does not ban us, I'm going to add an artificial delay between each loop for a few seconds so that the whole process repeats after every 2 seconds. And then we can just simply run this workflow and see the outputs of these as they become available. Once the workflow completes for both 2007 and 2008, we should see a lot of files here. Each of these files, the name of the file is the airport code. And I can see there's a lot of weather related data. The first one is obviously the timestamp, and then things like the temperature, mean temperature, so on. So obviously we have now accumulated a lot of weather related data that we want to start using in our workflows. So we'll continue building a workflow in RapidMiner to read all of that data. Obviously there are a lot of files, but we need to combine this data. Once again, RapidMiner provides powerful operators like loop files where I can specify the directory to use. And then internally I can read those files. It automatically loops through every single file. And then at the end of the day, I can append all of that data together and do some post processing like handling missing values, filtering out, data set with some missing values, and then storing it in my repository here. So once I run this workflow, we should have the weather data available. The next part of this workflow is combining the data from the flight data and the weather data that we just acquired. So what I'm going to do here is get the 2007 flights data and then the 2007 weather data, and then we need to blend this in together. Again, RapidMiner provides a lot of operators for handling different types of joins. Various techniques like left right join are available as a simple option here. So I'm going to specify this will be my left join, and we will configure the ID column to use. So this will be based on my day of the month and day of the month here, and then followed on by the month itself and the airport code. In this case, I'm going to do the destination first, and that is what I need to do. We'll repeat this process for combining the origin weather data too, and then the workflow should look something like this. I have the flight data coming and then combining that with the destination data first and the origin weather. And you'll notice I'm passing this out as a result set itself, and that is saved as the central workflow. Now that we have built a workflow to combine the weather data, let's see what else needs to be done with it before we can use it. We are going to simply run the workflow here and obviously have various columns here. But one of the columns that you'll notice here is the events column, which has flags for rain, snow, and other weather events. So we are going to use one of my previously created steps, which basically creates new columns based on the appearance of certain words in the events column. So we're going to have a binary column whether there was a fog event or not, or hail event or not. And then we are going to do something we did earlier. We are going to use one of the weighing techniques to see how each of these matter. So I'm going to use weigh by information gain and sort it in decreasing order to see what the output looks like. So here we have the output of the weights, including the weather data, and obviously you see some influential columns like precipitation, temperature, wind speed, and so on. So at this point it looks like we have a good enough data set to start trying to build our models. So let's go ahead and start doing that using the RapidMiner Studio client again. For our next process, we are going to use a validation technique by generating a ROC curve to see which of the models fit better. I'm going to open up this existing workflow that we have. In this workflow, we are basically reusing the 005 combined 2007 process. This is basically the process that combines your data with the weather data for both source and destination. I'm then doing some data preparation activities that we have seen in the previous workflows, basically creating the event flags. I'm converting some data types, and then at the very end, I'm getting rid of rows where there are missing values in any column. Later on, I'm passing this data to the compare ROC operator. It's a very simple operator. I provide the number of folds and the split ratio and what kind of sampling I want to use. If I double click inside, I can start building various models. So what I'm doing here is first building a gradient boosted trees with passing all the columns and a deep learning with all the columns. The third and the fourth model are here the gradient boosted tree with only without the weather data. So I'm just passing in the flights data that we earlier had. The same thing with the deep learning algorithm. And on the right side, on the bottom here, what we're doing is building models only with the origin weather data. So by doing this, I'm basically going to compare these two algorithms, how they perform when they have just the flight data, the weather data for the origin, and then with the weather data for origin and the destination. So to execute this workflow like before, we're going to hit the play button. RapidMiner is going to go ahead and process the details, and then the result will be available as a ROC chart. Here is our output for the ROC curve, and we have some clear indications. The DL, deep learning with both the weather data, obviously seems to be better. The next best one is the gradient boosted tree with weather on both the sides. So definitely having the weather information for both origin and destination seems to be promising. However, to verify this, I'm going to continue building on this workflows, and we're going to build some cross-validation models to see how it behaves. Going forward, we are going to use existing processes and walk through the setup that was done. So for now, I'm going to open the cross-validation workflow here. Similar to before, I'm reusing my previous preparation block. Inside, I'm doing some data preparation. I'm creating the columns for the weather events. I have a few steps here that I have disabled for now, and then I'm selecting only the columns that are from the original flight dataset, and also I'm filtering out dataset that has any missing values, and then I'm passing it along to a cross-validation operator here. RapidMiner provides various validation techniques. Cross-validation obviously is the powerful one. It automatically does tenfold validation, automatically does the sampling you select, and divides the data into training and testing part. On the training part, I can add a lot more than one algorithm. So for example, if I had a need to normalize the data before, and then I can go ahead and group this data set together or group the models together and combine and create a combined model that can be used for the training and the testing purposes. So the idea here is it provides a versatile framework for you to build models, combine different models, and still perform cross-validation in a very easy fashion. So for now, I'm just going to go back and do a few undos, and we will run the workflow here to build the deep learning model. The results of the validation are here. What I see is my model is around 63% accurate. So it's a good enough start. Obviously, we have ignored the weather data, as well as we can do some things like dummy coding of our variables. So I'm going to proceed to reconfigure those steps that we had initially ignored. These convert the necessary columns into binomial columns using dummy code mechanism. And let's go ahead and rerun the workflow to see what the output of this cross-validation looks like. The results of the cross-validation are here. This time we are getting the results after the dummy encoding, and I see a 3-point bump here, so definitely another good improvement to the model. So now let's rerun this workflow one last time with including the weather data. So to do that, I'm going to go back to my select attributes and ensure that I'm selecting the weather data itself and apply. Keep in mind we are doing an invert, so basically it's going to select everything except the events column. So let's go ahead and run this workflow one last time to see if we see any improvement by including the weather data, which will validate our earlier hypothesis, or what we saw from the ROC, that the weather data models seem to be working better. The results for our third iteration of cross-validation are back, and again this time with the weather data I see a bump of another few points. The accuracy is up to 70%. So it looks like we should be using the weather data in our model building process. Also, another thing here is, let's say the accuracy would not have improved, I could always go back to the result history and view at the previous iteration. So in this case, you'll notice the first one was 63, then 66, followed by the last one where we got an accuracy of 70. If for some reason, if you wanted to revert back to this workflow, all I have to simply do is click on this button, and that will restore the workflow back to what got us to that result set. So we can go back, iterate, and go back and change workflows to find the right result set very quickly. So far we have done cross-validation where our data set was the 2007 data set. Obviously, for this use case, we want to test it against a 2008 data set to see how it performs. So to do that, we're going to work on a new workflow here, the cross compare models. What I'm doing here is bringing in data from two different data sets, the 2007 data, 2008 data. I'm simply appending them. Then we are doing the data preparation like we have been doing before, the same stuff. And then again, I am dividing the data into a training piece based on the logic that the year is equal to 2007, and the unmatched data, which is our 2008 data, goes into the new model management operator. I'm simply creating two learners here, deep learning and gradient boosted trees with the 2007 data, and then I'm collecting and passing it to the model management operator. Now, to add one more algorithm to this, I'm going to use RapidMiner's ensemble models. If I search for the word ensembles, you'll notice RapidMiner has a rich set of ensemble models available. Random forest gradient boosted trees obviously are very common, but we also have various bagging, boosting, voting algorithms available. So for now, today, we're going to use the bagging algorithm. We are going to add in the data set. We are going to pass it along to the collect operator. Inside the bagging operator, I'm going to use a simple decision tree learner, and I'm going to change one parameter for the bagging, which is we'll provide 100 iterations, so it will actually create 100 decision tree models. At this point, our bagging model is ready, the gradient booster and deep learning tree, and we're going to run this workflow for getting which is the best out of these three models when it comes to testing against the 2008 dataset. Also, this same operator can be used for comparing models that are already saved in your repository. RapidMiner repository allows you to save workflows, processes, data, as well as models. You can simply drag in an existing model and pass it along to the model management operator. That way you can compare models that are currently built versus the models that are available in your production systems, thereby doing a competition between the models. And if our new models are better than the current models, then they'll be replaced. Otherwise, we will continue using the one in the production. But for the purpose of this demonstration, we'll go ahead and hit play and see what the results look like. As a surprise, it turns out my bagging model actually has the best performance here with an accuracy of 71% when it comes to testing against the 2008 data set. I'm also going to plot the data set which is captured here. So if I look at the location where all the data is saved, all my models are saved here under this folder. Their individual performances are also available, and I can look at the performance records of the models. So my bagging model's accuracy of 71% with a precision of about 63. The next best is gradient boosted tree 66 and 48, and this one 62 and 44. So it turns out bagging model actually is working out very well for our data set. The bagging model in this case is nothing but a decision tree of, or rather a collection of 100 decision trees, and they're already saved here so that I can later reuse for my future use cases. Now that we have found the better algorithm, maybe we can try to improve the performance of the algorithm by using one of our optimization techniques. RapidMiner provides various optimization techniques like optimization of parameters, allows you to do automatic feature selection, feature generation, and feature weighing. For the first part, let's say we want to do feature selection. We're going to open up existing process again here. What I have here, like we did before, was obviously I'm getting the 2007 data, the 2008 data, doing the usual data prep, and then I'm filtering it into the training set based on the condition 2007 year, and 2008 is my test data set. I'm also doing the weight by information gain to help the optimize feature selection. We are providing necessary parameters here. The optimize selection evolutionary operator is a meta operator. Inside of the operator, I am going to build a gradient boosted tree. I know our bagging and deep learning seem better, but for the purpose of this demonstration, we're just going to stay with JBT for now. I'm building the model, testing it against the 2008 dataset, capturing the performance, and I'm deciding how I want to optimize the model based on accuracy or the first selection or recall or whatever. So I can decide what is my main goal for optimization. And then I have a short sub process here that is basically storing all these intermediate models and the result set. When I Can then run the workflow here. What will happen is RapidMiner is going to try various combinations of features and save them, save all the models and their performance, and eventually just deliver me the best model and the performance and the feature set to work with. So let's go ahead and run it. Eventually, when the workflow finishes, you'll notice we have a log information here. This is the captured data while the iterations are running. RapidMiner actually built around 259 different models. We are doing the GBT here, and you'll notice for each of the iterations, we kept the depth at 20, but not try. We'll try different depth values in a bit here. And these are the model results. So if I just sort it by the accuracy, basically I can get up to 65% accuracy with a precision of 48.7. I've also saved the same log here in the repository. So let's go ahead and open it up. I can use this for later analysis if needed or later comparisons. But if I go to the charts view and let's say we plot the count on the x-axis, we definitely see a pattern where the model was improving in the accuracy, which is the y-axis, after several iterations, and obviously it kind of plateaued after a bit here. If I maybe try a different value, let's say AUC, the AUC kind of stayed almost constant through the whole thing, but maybe look at the precision perspective. But yes, our precision also improved along with the accuracy. So as you notice, I can go back and analyze this data, and maybe next time when I run another feature optimization cycle, I can compare this with the old data set to see if it helped or not. Similar to the feature optimization process, we have built a process here for parameter optimization. I'm doing the usual, getting the data, splitting into training and testing, and then I'm passing in the training part into a gradient boosted tree, and the testing, that is our 2008 data, to the apply model step. We're going to apply the model and capture performance, and I can select what performance vectors I want to capture. I can also decide what criteria I'm looking to optimize, so thereby the iteration would compare that particular criterion and deliver the one that is best. This is some housekeeping step to log and capture the models that are built along the process. One of the beauties of this approach is you could also build a cross-validation optimization step here. So instead of a separate training and test data set, I could simply put in the data in the validation operator. Inside will build the model, and then the average port here, that is your performance vector, can be passed along to the performance vector here, and thereby we can compare a cross-validated model against different iterations of values. But so far we have not decided which parameters we are trying to optimize. That is done by settings on the optimized parameters options here. If I click on the settings here, you'll notice it automatically discovers all the various operators that are inside. So I can select my gradient boosted trees. It will list out all the possible parameters here. I can then highlight one of the parameters, so move it to the right. So for example, for the gradient boosted trees, number of trees, I'm trying to optimize between 30 and 150 in 6 steps. So these are the unique values of number of trees that will be tried, and the maximal depth of 10 to 20 at 5 steps on a logarithmic scale. If I need to specify some hard-coded values, I could also go ahead and do that. I could simply start adding values that I need to test on, and then the number of combination obviously changes based on the hard-coded values you have. But for now, we'll just go with the initial combination, and we'll go ahead and run the workflow now. What I have here is the result of the optimized gradient boosted trees. We see all the various trees, and we can click through and see each of them in the graphical format or in the textual format here. But the key interesting thing here is the parameter set. So it turns out I can get an accuracy of about 68 with a value of number of trees equals to 90 and maximal depth equals to 15. We also have the detailed performance vector that we can learn from. While I'm building this model, I've also kept a track of all the iterations. So we have for each iteration, so the count is the iteration, the accuracy of the models, the precision, and the depth and the number of trees parameter. So between this, I have a history of records of what happened during that whole optimization cycle. Now, as you notice, I did the optimization for feature selection and optimization for parameter tuning separately, but I could also combine them into one workflow to try various combination of features and parameters in the same workflow here. At the end of the day, I could start storing these models by simply using the store operator and then provide a location on where to store it. Once a model has been stored, we can keep building on the existing workflow. So for example, I have this model building process here that delivers me the best optimized model. And then I can, let's say, compare that with one of my existing bagging models with the model management operator. And by doing so, I am now able to compare a model, let's say, that was used in production systems, and then compare and save the one that is the best among the two models. So it will basically be doing a challenger champion testing here using the optimized process, comparing that with the existing bagging model in production, which was saved here. And the one that is the best one will be automatically stored for later purposes. So you could have a process that automatically tunes your models, compare them against your production models, and then updates them only if your newer models are yielding better results. So far, what we have seen is we're using all this code-free drag and drop operators that enable the data scientist. However, it is also possible to include scripts based in various languages in RapidMiner that is provided by our operators like execute R and execute Python, as well as an execute script operator that takes in a GUI script. But instead of dragging this operator and configuring it myself, what I'm going to do is introduce another new thing that we do at RapidMiner. We have a very popular community website with around 172,000 active members. One of the options here is RapidMiner provides what we call as building blocks. We have seen the building blocks before in our demo. They provide a very easy way to build set of functionality together. So I've already downloaded this cross-validation using Python models in my workflow. And to bring in that Python code, all I have to simply do is insert a building block and pick the building block. One of them was my Python validation over here. So now if I need to do a Python validation, I can simply pass in the data here. We're going to get rid of everything else. And simply inside I have my Python script provided on the training side. I'm building a gradient boosted classifier using Python. And then on the right side, I'm applying the model using another Python script and then capturing the performance using the RapidMiner performance operator. So as you'll notice here, I've combined the best of both worlds. My data acquisition, my data preparation can be reused from all my previous activity. And then if I want to try an algorithm from the Python or R packages, we can definitely work on that. In a similar fashion, we can integrate with new packages like the one from TensorFlow, Theano, NLTK, OpenCV. Most of them provide actually a R or Python integration. So we are very easily able to extend the platform using some of these. Also earlier, we downloaded some data using the web services API for the weather, but the same concept can be extended to work with API-based products like Algorithmia or from Microsoft. The other benefit of using a technique like this is, as you notice, I'm able to reuse a lot of my code-free nature. But then if you want to do things like validation or optimization that we saw earlier, they can also be used for packaging your R or Python scripts. So R or Python programmer is going to just write a baseline script, and then rest of the activities can be concluded using the code-free activity. You typically see a very short script compared to what typical Python programs look like when they're combined to use with RapidMiner. And on top of it, you get additional benefits of being able to put this in an enterprise scale platform, scheduling, web service, and all that, which we'll talk about in a bit here. We're going to shift gears here and I'm going to talk about a different data set. What we're trying to show you here is some of the advanced capabilities that are available with the RapidMiner platform. RapidMiner is enriched by several extensions that are provided by its own engineering team, coming out of other partner projects, as well as extensions that come from third-party companies. For example, the text processing extension in RapidMiner is very popular for various use cases like sentiment analysis, clustering of documents, classification of documents. Everything is powered by the same drag and drop concept. The workflow here in the gray is what is our text mining extension based workflow. Similar to what we have been doing, we are getting the data, providing the role for which column is our text column, and then the RapidMiner process document operators allows you to create word vectors from your data set. Inside of this operator, we do standard things like tokenization, transforming of cases, filtering stop words, and based on your needs, you could add other things like stemming or filtering tokens based on some dictionary words, English words, or even extract entities and many others. One other operator that we're going to use here is the WordNet dictionary operator for extracting sentiments for English words. As you'll notice, a simple drag and drop workflow I can build in a few minutes can then be used for extracting sentiments, and then I'm selecting the necessary outputs and passing it along. Along with the text mining extension that we provide, RapidMiner has also integrations coming from two more companies, one of them being Alien, which provides additional text mining capabilities like sentiment analysis, language detection, extraction of phrases, and then several other advanced operators based on natural language processing technique. A similar extension is available from the Rosette text mining toolkit. So just to show you those three techniques in action, I'm going to hit the play button here and show you the results. The results look something like this. Here I have one of them providing just a positive or negative sentiment value. One of the extensions goes further and talks about subjectivity, polarity, and so on. And then with the RapidMiner extension, you get a score. I have obviously ignored a lot of columns here. So as you notice, it's easy to build sentiment analysis, but with the RapidMiner extension, it provides you basically a lot more in terms of what you can do. Here we're looking at the tokenized tweets. Using this mathematical representation now, I'm able to build additional workflows like clustering of the documents, where each row is my document, or maybe when doing some sort of classification based on some training data set. The same text mining extension allows you to work with various file formats like PDF, HTML. It can be combined with the power of the web mining extension we talked about earlier to do a lot of unstructured data mining solutions. Another example of some of the advanced techniques enabled by RapidMiner is this extension that comes from a partner of ours. They provide image mining extension that works in RapidMiner and works on the same principle of easy drag and drop workflow building. What you're looking at right now is some sort of web-based solution they're put together that is powered by RapidMiner. I can pass it URLs. For example, I'm going to pass it URL for this particular image here, and we'll notice that how it classifies that as an airliner with 87% confidence probability. Let's try that with another URL here and see what the results look like. As you notice here, the front end of this application is obviously not RapidMiner, but behind the engine is a RapidMiner extension working with the RapidMiner server and providing results to a powerful website. For the next part of our demonstration, we're going to start leveraging the RapidMiner server product. For example, my workflows can be saved in a central location like I have here in the RapidMiner server-based repository. The server-based repository, first thing it provides is obviously multiple users can talk to the same server using their own unique username password. These are local username passwords or could be LDAP username, and thereby your authentication will be LDAP. Each of the servers can have multiple folders for individual projects and groups, and each of those folders could have various levels of permissions. For example, my dashboard developers can only execute some workflows, whereas maybe my data scientists can do every single thing. So you'll notice there's a lot of granularity in terms of how you can assign permissions to the workflows, and you can obviously go ahead and assign overriding permissions on subfolders and so on. Once these workflows are available in a central location, they become reusable, and certain workflows obviously cannot be run on your regular desktop laptop class of machines. They need sometimes more computing power. So a workflow that was built using the RapidMiner Studio client can simply be run on a RapidMiner server by selecting the right option here, by selecting run process on the server. You'll also notice at this point, RapidMiner is asking you to select from a list of queues. Queues are nothing but a way to manage resources on the server. A server would be shared between teams, and depending on your permissions, you'll have access to certain queues, or the queues allow you to control how many of these jobs can run in parallel, how long to wait before the job would be killed automatically if it does not get a chance in the queue, and if there are certain jobs that are of a high priority queue, like the real-time scoring queue, they obviously would have unlimited resources taking priority over other queues. So RapidMiner server ensures that a collaborative environment is available, but at the same point making sure that things that need to be prioritized are correctly prioritized. Submitting a job to a server class machine obviously lets you use more RAM and more CPU cores, thereby speeding up the whole processing time dramatically. Also, it enables user to submit bunch of jobs in parallel to run on the server, and thereby get a lot more done in the same amount of time frame that they would have been otherwise not be able to do on a regular desktop class of machine. Data scientists can simply move their workflows from their local development environment into the staging environment by simply copy pasting into the appropriate server locations. That would be simply done by copying and pasting wherever is the appropriate location. After that, the admins for the production server may be able to run some test or do an automated workflow where they are going to take a backup of our current workflow, move from staging to the production environment with another operator from RapidMiner, and if everything goes well, send a success email. And if not, they can do a restoration of the backup by using one of our move operator and then again sending a failure email. So as you notice, everything can be automated in terms of moving the workflows and the model from one environment to the other. Today we have spent time predicting the flight delay, so let's go ahead and see how you can deploy these models using RapidMiner. RapidMiner models that are stored in the repository can simply be dragged into a workflow for scoring purposes. Let's say after that I want to use a read database operator to get the data I really want to score on. I'm going to pick my connection to use, and then I'm going to pick the query from where to get the data I want to score on. After this, obviously remember we had done a lot of data prep today. I want to do similar data prep, so I'm going to reuse one of my building blocks like before. Then we are going to connect the necessary inputs and ports, and then we'll use a apply model operator, a generic operator that combines the model and the data set to give you the predictions. The apply model is generic enough, so if one of our model management techniques had saved a gradient boosted tree or maybe even a linear regression, it is transparent to that. The same operator can handle various different models and give you the predictions. To continue building on this workflow, I'm going to open an existing workflow and discuss what's going on here. So we can have the exact same workflow like we did, but let's say our use case was every single day, whenever we update the weather data, we want to run this workflow and predict the top 200 flights that are going to be delayed. So I've done that here, and we can simply now run the workflow either locally or on the server as needed. But obviously running it here is of no good use. So what I probably want to do is at the end of the workflow, when I have sorted based on the decreasing values of confidence and then picked up the top 200 flights, I figure out which columns I really want to provide as a dashboard or result set, generate a few extra columns for reporting purposes, and then I can start writing this out to various formats like Excel, CSV, database, Salesforce, S3, and so on. So you can now not only build the models, apply the models, you can take the prescriptive action after that and provide the results in the right place at the right time. And once a workflow like this has been built, you can simply go ahead and schedule, as we described earlier, at a frequency that is needed. Batch programming works in many cases, but obviously there are many use cases where a real-time need for predictions is urgent. But in the context of this demo, let's say you wanted to ask the system, hey, tell me the top 5 flights to avoid if I want to travel between two airports. So what we have done in this workflow is added some context variables. These are nothing but parameters that I'm going to pass. So like the origin, destination, and top, how many airports I want to look at. Every RapidMiner workflow can then be converted into a web service by simply right-clicking and hitting on Browse. That takes you to our server interface. You then go ahead and click on the Export as a Service option here on the right. We will then say copy from context, which ensures the parameters are in sync, and then hit submit to save and create a web service endpoint. We can go ahead and test the web service here or edit it further. But to show you this in action, I'm going to call the web service from a browser interface here. We have the web service endpoint. I'm passing in the parameters that I want origin and SFO, and give me the top 20 flights that are highly likely to get delayed. But instead of that, if I say give me the top 2 flights, I know I should not be traveling on the 10th of April on the 6 o'clock flight. In this case, we have the data in XML format, but obviously if we need other formats, I could simply go back to my setup page and then decide various formats like JSON, OData, or I could also start creating charts using the RapidMiner's graphics library and deliver graphical outputs directly to my dashboarding system, whether hosted by RapidMiner Server or by third-party systems. Another technique for deploying models could be providing them as PMML models. PMML write operator basically does that for us. You simply need to plug it into the workflow, pass it along a RapidMiner model, and then provide a location where the PMML output should be written and what version it should utilize. Another deployment technique RapidMiner provides is the ability to call a RapidMiner engine in a command line mode. I could simply do this by calling the RapidMiner batch shell script or the batch script that is available as part of the installation. I then need to pass the location of the process I want to run. This location is nothing but the repository location, so I can easily just copy it and paste it there. And then the various inputs that are needed for the workflow can be passed along. This workflow will then start with a headless client mode, run the process, and then deliver the results as designed by the process or as configured by the various parameters. So this allows you to run RapidMiner in a production mode without any GUI interface on top of it. One another deployment technique that you can also leverage is if you want to integrate tightly with a Java program. RapidMiner provides classes to integrate the engine with any Java program. The code looks very straightforward. I have to initialize the RapidMiner engine. I can then pass it along the RapidMiner process file. We'll look into the process file in a bit detail here. Then we pass the origin, destination macros or any of the variables you want to pass along. If there are specific operators you want to override, you could also go ahead and do that. So you have the flexibility to pretty much control any of the parameters. And then you obviously go ahead and execute the workflow. So this way you can tightly embed a RapidMiner engine into any Java application. The one additional benefit you have here is you're going to pass what we call as the RMP file or the RapidMiner process file. A RapidMiner process file is nothing but a XML representation of the workflows. You can simply see that using the show panel XML option in the RapidMiner Studio client. Every process internally is represented in a readable XML format, and this is what the Java integration requires. So once you have built a Java integration, you could keep changing the workflow, you could add new steps, you could change the models and whatnot, and when you update the reference or rather the actual file that needs to be used by the Java program, you do not need to recompile or rebuild your Java code again. So you could be continuously running this Java workflow and then keep updating the workflows as needed outside the system and change the parameters as well as other options needed in real time without having to recompile the Java system. Another common deployment technique for RapidMiner users is building what we call as apps. These are web apps that are powered by RapidMiner workflows behind the scenes. So for example, here I have a screen where I'm prescribing which weekdays to follow or which hours of the day should be used for departure to avoid the most number of flights. We could also add some simulations and what if analysis to this. So for example, if I say, we will say Atlanta, let's see what the output looks like for that. And maybe if I go ahead and say, if let's say there were 10-inch rain versus 5 inches of snow versus the temperature dropping by 5 degrees, what is the output prediction looks like. And here is the output of it. It seems like snow obviously has greater impact towards the end of the day. So again, you could build a rich web app for people to provide prescriptive analytics as well as simulations. This part demonstrates RapidMiner's capabilities with the Hadoop ecosystem. RapidMiner provides an extension called as RapidMiner Hadoop that will allow you to work with many of the Hadoop vendors out there. The workflow is pretty straightforward. You basically define a Hadoop connection, specifying which flavor of Hadoop you are using, what version, and some basic URLs and ports and so on. Once that has been provided, RapidMiner provides a quick overview into the Hadoop data view. I can explore the various tables in that Hadoop cluster, and I can also see some sample data, and also the same statistics and charts overview that we saw initially are available for the Hadoop data. But the real power of the platform is over here. In our use case today, earlier we were working with the ORD dataset, but in this case I've already loaded a lot of data into Hadoop using the RapidMiner Hadoop operators for storing in Hive. And then we are building a workflow to exactly what we did earlier. So retrieving the data, setting which target we are trying to predict, some data conversions and so on, and then doing a validation on a decision tree algorithm, and then capturing the performance and seeing the results. The beauty of this workflow is once I hit the play button, this gets converted into underlying Hadoop technologies like Hive, MapReduce, etc. And the results are then delivered back to RapidMiner. When completed, you should be able to see the 3D representation of the model itself. And then we can also check the performance quickly here. So as you can see, I was able to build a decision tree model using the Spark ML library without writing any code. However, if need be, this also supports including your Spark scripts, which support both R and Python languages. So I can simply add it to existing workflow and then provide my script code inline in either Python or R languages. One of the additional benefits provided by RapidMiner Hadoop process is it can use any of the models that are built on a non-Hadoop system to score on Hadoop. So you could do your data prep ETL on Hadoop, move some data out to build the models out of it, and then when the models are ready, you could send back the models to Hadoop for scoring hundreds or billions of rows. You can also combine RapidMiner operators with a Hadoop workflow. So I can use this operator called as single process pushdown and then use any of our 1000 plus operators inside this workflow. RapidMiner automatically coordinates working of the core operators into a Hadoop ecosystem when they are embedded in the single process pushdown operator. For new users, RapidMiner provides various ways to get started with and get productive with the platform very quickly. For example, when I hit the new button here, one of the options I have is to follow along some inbuilt tutorials. So I can now pick and follow along a step-by-step guide and complete the steps as suggested by the tutorial. These tutorials cover a vast variety of topics from just getting started to model scoring, validation, and so on. Also, along with that, most of our operators can be selected, and on the right side, we provide very detailed help in terms of what the operator does, inputs, outputs, and so on. And then also, many of them would have an embedded tutorial process that I can simply launch from inside and then follow along the tutorial for that particular operator. Also, for a lot of operators, we provide what we call as wisdom of crowds. This is based off our community of hundreds of thousands of users who use our product regularly, and we can, based on their usage patterns, recommend new users how they should be using the system. For example, for a decision tree operator, if you're not sure what should be the value of the depth P, you can expand on these green arrows to see that 77% of the users stay with the value between 20 and 29. If you're not sure of what your criterion should be, again, simply the system will make some recommendation in terms of how it should be configured. Not only that, at the very bottom here, you'll notice it recommends various operators. So I can simply attach operators directly by dragging it into the workflow from here. It provides a lot of visual cues. For example, the exclamation mark here kind of demonstrates something is wrong. I can click on it and it will provide me the necessary guidance. If you still happen to execute the workflow without the necessary connections, it will complain again where things seem wrong. Last but the most important aspect of the project for new use cases is we come with inbuilt templates for various popular use cases out there like direct marketing, churn modeling. These are highly detailed use cases that you can simply launch by clicking on the options here. We provide a complete setup with some sample data. In most use cases, you should be able to just replace the data prop set with your data set, provide some necessary data preparatory steps, and then build the model that this particular template provides. Additionally, you can build your own templates and can distribute across your team as well as to our broader community through the RapidMiner marketplace. RapidMiner marketplace provides a lot of pre-packaged solutions for various specific problems, including text mining, anomaly detection, outlier detection, Weka library, process mining, and many, many more. So as you'll notice, there's a lot of solutions that make the ecosystem a rich solution for many use cases out there. With that note, thank you for the opportunity to present RapidMiner to the Gartner team here.